There is a cylinder. This is the axis of the cylinder. There are electric fields which are parallel to the cylinder axis of the cylinder. We need the question is to calculate flux here. So the formula of the flux is E dot A, electric field, dot product of electric field and area. Here both are in same direction, so it is very simple. And here we need to calculate the outward flux. So the area is this surface. So it is very simple. So it is just E pi r square. That is option B. This is again a very simple question. If uh, one can frame this question in mind, this question is very easy. Let us consider a dipole and its axis. Let us draw a perpendicular bisector of this dipole axis. So we need to calculate potential, the total potential due to this dipole or these two charges, opposite charges, at any point in the bisector. So let us this distance be r, and we know from this properties of triangle, we know these distances are equal. So the total dipole is given by for positive charge, that is kq by r. For a negative charge, minus kq by r. So the answer is 0. That is option C. After reading this question, it is clear that we need to find out the relation between F and V here, this force and the potential difference. So to do this, what we do, we can write here this kinetic energy half mv square is the kinetic energy comes only from this electrostatic potential. So we can write this half mv square is equal to ev. From this we can calculate the velocity as 2 ev by m root over. From Lorentz force expression, I know that F is equals to Q, or here electron, so E V B. So if we put this V here, we can see the total expression is EV square root E V, the potential, upon M. So here we see the force is proportional to square root of V. That implies is that force square is proportional to this potential V. So from this relation we can easily see, from this relation we can easily calculate that F1 square divided by F2 square is equals to V1 by V2, or here V prime by V is equals to 2F square by F square. So if you read this question, it is clearly mentioned that A naught is 10, that peak is 10. Your frequency is 50, time is 1 by 600. So we need to calculate this EMF. So this is E naught cos omega t. If we expand this omega, this is 2 pi f t is t. So now cos E naught, this is 10 cos of 2 into pi into 50 into 6, sorry, 1 by 600. So this is 100, this is 6, pi by 6, cos pi by 6 is 1 by 2, so 5. So this is the answer. And this is option C. So here the problem is to calculate heat generated in the loop from a time varying potential. How we will going to calculate it? If we want to calculate this heat, we need to first calculate this power. We can get this power if from this EMF and resistance, and we know we can easily calculate this EMF from the law of induction, from this time varying potential we can get this EMF. So this EMF is minus d phi by dt. So if we took this derivative, it is minus a t plus 2a t. So your power is given by E square by R. So it is minus 80 plus 280 whole squared divided by R. Heat from power, we need to do the time integration of power. The time is given between the interval 0 to t. So let's calculate this integration. This is very simple integration. You can easily calculate it. Just expand this to 1 by r outside because it doesn't depend on t. So if we integrate it, it's 2a square plus 4a squared t squared minus 4a t, sorry, a squared t t dt. Integration 0 to t. This becomes 1 by r my a t square t plus 4a square t cube upon 3 minus 4a square t t square by 2 0 to t. We do it. This is in the bracket. Set a bracket. So 1 by r. So this is everything. If we put 0, this is 0. So the only upper bound works. So it is minus, sorry. So inside this, it is a t cube, a square t cube plus 4 by 3 a square t cubed minus 2 a square t cubed. If we solve this expression, we're going to get a squared t cube by 3r, which is option A. This is a very easy question. This is Maxwell's third law, and it is related to Faraday's law of electromagnetic induction. So option D is correct. This is again a very easy question. The ratio of E and B in Maxwell's relation is C. So option B is correct. This is again a formula based question. To do this question, you need to remember the formula of this reflection coefficient. It is this n1 minus n2 divided by n1 plus n2 whole square. The option A is correct. This is actually the derivation is very long. You can find this derivation in any standard book, for example, in Griffith. There is a chapter called Electromagnetic Waves in Matter. So you can go to the section called Reflection and Transmission at Normal Incidence. As a specific section, and in the last point of this section tells you this reflection coefficient and transmission coefficient. So from that you can check this derivation. This is again a single formula based question. So we know that the polarization intensity formula is I is equals to I0 cos square theta, where theta is angle between this axis of analyzer and your polarization of your light, polarized light. So here it is given I is equals to I0 by 4. So from these two relation you can get sorry you can get cos square theta is 1 by 4, so cos theta is 1 by 2, that implies theta is 60 degrees. Sorry. There is a formula to calculate this thickness of a half wave plate, that is lambda over 2 1 by is mu E minus mu 0. So if you calculate with the formula, the answer is coming 2.5, which is option D. Here is also a formula to calculate the equivalent, that is 1 by f0 is equal to 1 by f1, 1 by f2 minus d, that is the distance between the lanes, f1, f2. So if you calculate with this formula, this f naught is coming 4 centimeter. So the answer is B. Okay, so this is a literature question. The condition for this bright and dark fringes for Newton's ring and transmitted and reflected lights are reversed. Like so, because this reflected ray has a phase change of pi, and transmitted ray has no phase reversal. So this is the correct answer. This is also a formula based question. So the radius is square root of frequency and wavelength. So if you calculate this, the answer is coming 5 into 10 to the minus 2. So it is C.